This is section 222. We're going to graph absolute value equations. So we're going to be able to graph absolute value equations in this lesson. Now, if you recall, we said that we can take an absolute value equation and we're going to split it into two versions, a positive and a negative version, right? Because that's the definition of an absolute value. There's a positive and a negative version of whatever's inside that absolute value. And we can construct it as a piecewise function. Now, we're going to technically use this process to be able to graph them, but because we're in integrated 3, we're not going to go to the full extreme of the definition. This is something that we examine a little further when we get to pre-calculus. So let's look at the absolute value of x minus 3. Now, there's a few ways for us to visualize this, right? We know that the parent graph, we know that there's a horizontal shift of 3, so it can shift over 3 spaces, but we need to be a little accurate with it. So it's always a good idea, and it's going to look like that, but it's always a good idea to pick points. So let's start with 3. If I plug in 3, I get 0. If I plug in 4, 4 minus 3 is 1. If I plug in 5, 5 minus 3 is 2. If I plug in 2, 2 minus 3 is negative 1, but the absolute value of negative 1 is positive 1. And if I plug in 1, 1 minus 3 is negative 2. The absolute value of negative 2 is 2. So we can now plot the points. So 3, 0, 4, 1, 5, 2, 2, 1, 1, 2. And there's our graph. So let's look at an example here. It says let's graph this, find the zeros, x and y intercepts, determine the domain and range, intervals of increase and decrease, and any absolute extrema. So absolute value, right, has a vertical shift of negative 3, so it's going to move down 3 spaces, and then we can go through and we can plot our graph. So let's do that, but we're going to make this a little bit more accurate. So here's our table. If I plugged in 0, 0 minus 3, negative 3. If I plug in 1, absolute value 1 minus 3, that's going to be negative 2. If I plugged in negative 1, absolute value negative 1 is positive 1. 1 minus 3, it's going to be negative 2. That should be kind of good enough because we know the shape of an absolute value. So now we need to find the zeros. So for us to find the zeros algebraically, the zeros are where it's 0, where y equals 0. So we can set our equation equal to 0, and we can solve. Add 3. Remember to get rid of the absolute value. You replace it with a plus or minus. And then now that's plus or minus 3. And so those are my zeros. Now visually, that's where it would cross on the graph. Now my x and y intercepts, I can look at my graph and I can determine that my x-intercept is going to be negative 3, 0 and positive 3, 0. My y-intercept is going to be 0, negative 3. The domain and range, my domain, right, if I were to flatten and project it, that's negative infinity to positive infinity. The range, if I were to project it, that's going to be from negative 3 to infinity. Intervals of increasing and decreasing, it's decreasing and then increasing. So it's going to be decreasing from negative infinity to 0 and increasing from 0 to infinity. And then absolute extrema, I have a minimum of negative 3. Remember, what measures how high or how low something is is going to be the y value. So what did we learn today? We talked about and investigated graphing absolute value equations further. This does conclude our lesson. If you have any other questions, please leave them in the comments.